Look at your hand right now. Hold it up in front of your face. It looks solid, doesn't it? It looks like skin, bone, muscle, and blood. If you slap it against the table, it makes a sound. If you pinch it, it hurts. It feels real. It feels continuous. It feels like it is definitely 100% there. But what if I told you that you are lying to yourself? What if I told you that your hand is actually 99.99999% empty space? What if I told you that the only reason your hand doesn't pass right through the table like a ghost is not because of matter, but because of invisible force fields repelling each other? And what if I told you that the tiny particles that make up that hand, the electrons spinning around the nucleus of your atoms, are not actually things at all? They are not little balls of matter. They are ghosts. They are clouds of probability. They are there and not there at the same time. And the scariest part, they might only exist because you are looking at them. For thousands of years, we thought the universe was a machine. We thought it was a giant clockwork mechanism. We thought that if you knew the position and speed of every particle in the universe, you could predict the future perfectly. We thought reality was objective. We thought that if every human died tomorrow, the moon would still be sitting there in the sky exactly as it is now. But then, about 100 years ago, a group of scientists looked deep into the heart of the atom. They wanted to see the gears of the clock. They wanted to see the bottom layer of reality. And what they found terrified them. They didn't find gears, they didn't find certainty, they didn't find a solid foundation. They found magic. They found a world where things can be in two places at once, a world where things can communicate faster than the speed of light, a world where the past can be changed by the future. A world that doesn't seem to make any sense at all. This is the world of quantum physics. And if you are ready to have your entire concept of reality shattered, if you are ready to realize that you are not just an observer of the universe but the creator of it, please hit that subscribe button right now, because we are about to go down the rabbit hole and there is no coming back. Most people hear the words quantum physics and they tune out. They think it is just for geniuses with messy hair writing equations on chalkboards. They think it has nothing to do with their daily life. They are wrong. Quantum physics is not just about atoms. It is about you. It is about consciousness. It is about the very nature of existence. To understand it, we have to start with the most famous, most mind-breaking experiment in the history of science. The double-slit experiment. Imagine you have a wall with two vertical slits cut into it, and behind that wall there is a screen. Now imagine you have a machine gun that shoots tennis balls. If you fire the tennis balls at the wall, some will bounce off, but some will go through the slits and hit the back screen. If you look at the back screen, what do you see? You see two bands of marks, two lines where the tennis balls hit. This makes sense. Two slits, two lines. This is how matter works. This is how the real world works. Now let's shrink it down. Instead of tennis balls, let's fire electrons. Tiny subatomic particles, the building blocks of matter. We fire the electrons at the two slits. We expect to see two bands on the back screen. But we don't. We see an interference pattern. We see many bands, the kind of pattern you would get if you threw two rocks into a pond and the ripples crashed into each other. This is strange. This means the electron isn't acting like a tennis ball. It is acting like a wave. It is going through both slits at the same time, interfering with itself and hitting the back wall. Okay, the scientists said, electrons are waves. Weird, but we can accept that. But then they got curious. They wanted to see it happen. They wanted to know which slit the electron actually went through. So they put a sensor, a tiny camera, next to the slits. They wanted to spy on the electron. They wanted to catch it in the act. They turned on the camera. They fired the electrons again. And this is the moment that broke physics. When the camera was watching, the electrons stopped acting like waves. They went back to acting like tennis balls. Two bands appeared on the screen. When the scientists took the camera away, the interference pattern came back. Do you understand what this means? The electron knew it was being watched. When it was unobserved, it was a wave of infinite possibility. It was everywhere at once. But the moment a conscious observer or a measurement device looked at it, it snapped into a single position. It decided to be a particle. It behaved differently because you were looking at it. This is called the observer effect, and it implies something terrifying about our reality. It implies that the world doesn't exist in a solid state until you look at it. It implies that behind your back, the universe is just a blurry soup of energy. But when you turn your head, it quickly renders the room, the furniture, and the walls, just like a video game loading the level as you walk into it. Einstein hated this. He hated it so much. He said, "I like to think that the moon is there even if I am not looking at it." But quantum physics says, maybe it isn't. Maybe the moon is just a probability wave waiting for your eye to collapse it into a rock. This brings us to the second mind-bending concept, superposition. You have probably heard of Schrödinger's cat. It is a famous thought experiment, but most people misunderstand it. They think it is just a riddle. It is not a riddle. It is a description of reality. Here is the setup. You put a cat in a sealed steel box. Inside the box, there is a tiny bit of radioactive material, a Geiger counter, a hammer, and a vial of poison. If one atom of the radioactive material decays, the Geiger counter detects it, drops the hammer, breaks the vial, and the cat dies. But radioactive decay is a random quantum event. You cannot predict when it will happen. So you seal the box, you wait an hour. Is the cat alive or dead? Common sense says it is one or the other. It is either purring or it is a corpse. But quantum mechanics says, no. Until you open the box and look, the cat is both alive and dead at the same time. It isn't a superposition of states. The universe has not decided yet, the timeline has not split, the reality has not formed. It is only when you open the lid, when you become the observer, that nature is forced to choose. Snap, the cat is alive, or snap, the cat is dead. But before that moment, it was a ghost. Now you might say, okay, that applies to tiny atoms and imaginary cats, but I am a human being, I am big, I am real, I am not in a superposition. Are you sure? Think about your life, think about the choices you make. Many physicists believe in the many worlds interpretation. They believe that every time a quantum event happens, every time the universe has to make a choice, it doesn't actually choose. It does both. It splits. In one universe, you open the box and the cat was alive. In another universe, you open the box and the cat was dead. In one universe, you clicked on this video. In another universe, you scrolled past it. In one universe, you married your high school sweetheart. In another universe, you moved to New York City and became an artist. In another universe, you died in a car crash when you were 17. This theory suggests that there are infinite versions of you, living out every single possible variation of your life right now, parallel to this one. You are just tuned into this specific channel. You are just conscious of this specific timeline. But the others are just as real. Does that make you feel small, or does it make you feel infinite? It means that every regret you have is unnecessary because somewhere you made the right choice. Somewhere you are living the life you dream of. But let's go deeper. Let's talk about the scariest concept of all. Entanglement. Einstein called this spooky action at a distance. He refused to believe it was true. He died trying to disprove it. But he was wrong. We have proven it. Quantum entanglement is when two particles become linked. They become soulmates. Their properties become connected. If you take two entangled electrons and you spin one of them up, the other one will immediately spin down. They are always opposites. They are always balanced. That part is fine. But here is the spooky part. You can separate these two particles. You can put one in a lab in New York and the other in a lab in Paris. If you measure the New York particle and find it spinning up, the Paris particle will instantly, and I mean instantly, snap into spinning down. Faster than the speed of light. It doesn't matter if they are across the room or across the galaxy. If you put one particle on Earth and the other one on the other side of the universe, billions of light years away, the connection is still instantaneous. How is this possible? Nothing travels faster than light. That is the cosmic speed limit. If you sent a radio signal from Earth to Mars, it takes minutes. If you send a signal to the next galaxy, it takes millions of years. But these particles communicate in zero time. It implies that space is an illusion. It implies that distance is not real. It implies that on some fundamental, deep level, everything in the universe is touching everything else. Think about the Big Bang. 14 billion years ago, all the matter in the universe was concentrated into a single point, a singularity, smaller than an atom. Every particle in you, every particle in me, every particle in the sun and the stars, we were all crushed together in that same tiny dot. We were all entangled. Then the universe exploded, it expanded, it threw us all apart. But if quantum entanglement is true, then we are all still connected. The atoms in your left hand are entangled with the atoms in a star a billion miles away. The atoms in your brain are entangled with the atoms in the person you love. Maybe that is why you can feel when something is wrong with someone you love, even if they are on the other side of the world. Maybe that is why you feel a connection to strangers. It isn't poetry, it is physics. We are not separate islands. We are one giant, shimmering web of energy, pretending to be separate individuals. Now, I want to talk about something that sounds like pure sorcery, but is actually used in the technology you are holding in your hand right now. Quantum tunneling. Imagine you are standing in front of a massive 30-foot concrete wall. You want to get to the other side. In the classical world, the world of Isaac Newton, you have two choices. You can climb over it or you can smash through it. If you don't have the energy to do either, you are stuck. You bounce off. But in the quantum world, there is a third option. You can simply walk through the wall. You don't break it, you don't climb it, you just appear on the other side. This happens because particles are waves. A wave doesn't stop abruptly. It has a tail that extends through barriers. There is a small but non-zero probability that the particle will be found on the other side of the barrier. And because the universe runs on probability, sometimes it just happens. The particle disappears from one side and reappears on the other. It teleports. This isn't theory. This is how the sun works. The sun shines because hydrogen atoms fuse together to create helium, but hydrogen atoms repel each other. They have the same electrical charge. It is like trying to push two north poles of magnets together. They push back. The sun is hot, but it isn't hot enough to force them together. By all the laws of classical physics, the sun should not ignite. It should be a dark ball of gas. So why does it shine? Because of quantum tunneling. Every once in a while, a hydrogen atom cheats. It borrows energy from the future. It tunnels through the barrier of repulsion and fuses with another atom. It is rare, but because there are so many atoms in the sun, it happens enough to light up the solar system. Think about that. The light on your face, the warmth on your skin, the plants growing outside, your very existence. It is all possible because particles can walk through walls. It is all possible because the universe allows for the impossible to happen. So what does all of this mean for you? Why should you care about double slits and entangled electrons? Because it changes the way you view your own life. For centuries, science told us that we were insignificant. It told us that we were just accidental biological scum on a random rock orbiting an average star in a meaningless universe. It told us that matter is dead, that consciousness is just a chemical reaction, that we are just observers watching the movie of life, unable to change the script. Quantum physics flips the script. It tells us that the observer is central to the reality. It tells us that without you, the universe is just a ghost. You are not just a passive victim of reality, you are a participant. Your attention, your focus, your consciousness is the glue that holds the world together. There is a theory called the simulation hypothesis. You have probably heard of it. Elon Musk talks about it. The idea is that we are living in a computer program. Quantum physics provides the strongest evidence for this. Think about a video game. In a video game, the computer doesn't render the entire world at once. That would crash the processor. It only renders what the player is looking at. If you look at the mountain exists. If you turn around, the mountain disappears and becomes code. That is exactly what the double-slit experiment shows us. The universe is efficient. It only renders reality when a conscious mind demands to see it. It suggests that this life, this pain, this joy, this struggle might be a playground, a school, a simulation designed for our growth. It suggests that death might not be the end. If energy cannot be created or destroyed, and if consciousness is a fundamental part of the quantum fabric, then what happens when the body dies? Maybe the signal just goes back to the cloud. Maybe you just wake up from the dream. There is a famous quote by Niels Bohr, one of the fathers of quantum mechanics. He said, "If quantum mechanics hasn't profoundly shocked you, you haven't understood it yet." It should shock you. It should make you dizzy. It should make you look at your hand again and realize that you are looking at a miracle. You are looking at a cloud of energy that has decided to be a hand for a little while. You are looking at a collection of atoms that were forged in the hearts of dying stars, traveled across the galaxy, and came together to form you. And those atoms are following rules that defy logic. They are blinking in and out of existence. They are talking to each other faster than light. They are reading your mind. You are not made of matter. You are made of possibilities. You are a wave of infinite potential, collapsing into a human experience. So the next time you feel stuck, the next time you feel like your life is set in stone, the next time you feel like you have no choices left, remember the electron. Remember that until the measurement is made, anything is possible. Remember that you are in a superposition of success and failure, of happiness and sadness. And you, the observer, have the power to collapse the wave. You have the power to choose which timeline you want to live in. The universe is waiting for you to look at it. It is waiting for you to tell it what to be. Don't let the world tell you what is real. You tell the world what is real. I want to leave you with one final thought, a thought that keeps me up at night. If the universe requires an observer to exist, and the universe existed for billions of years before humans evolved, then who was observing it? Who was the first observer? Who looked at the Big Bang and collapsed the wave into the galaxies? Science calls it the observer, religion calls it God. Maybe they're talking about the same thing. Maybe we are just the universe trying to understand itself. I hope this video broke your brain a little bit. I hope it made the world feel a little more magical, a little more mysterious, and a little less solid. If you enjoyed this journey into the rabbit hole, please hit that like button. It helps the algorithm find other observers. And hit subscribe because we are just scratching the surface. In the next video, we are going to dive into the concept of time and why the past might not be as fixed as you think. Let me know in the comments, do you think we live in a simulation, or is the universe just weird? Stay curious, stay open, and remember, nothing is real until you look at it.